Hi, it's Mr. Baumgarten, and we are working our way through the practice round of coding quest challenges. And we have the last one left to go, message from afar. Okay, this one uses a compression algorithm where the most commonly used letters only require 4 bytes, and then there's a number of letters here that have 5 bytes of data attached to them, and then we've got a number of letters and the digits and some punctuation that have 7 bytes each. And so the idea is, as you read through this left to right, there is only ever one pattern that can match what, it can only match one letter there. Right, so here, for instance, we see the first 2 bits are 1, 1, so that means it has to be one of these 7-bit characters. So I can read 7 bits from that, 1, 2, 3, 4, 5, 6, 7. Right, so it's 1, 1, 0, 0, 0, 1, 1, which if we look up here, 1, 1, 0, 0, 0, 1, 1. That is the uppercase letter G. And so then from this point, we keep on going. If 0, 1, okay, well that means it has to be up here. It has to be one of these 4. All right, and they're all 4 bits. Where was I? So 0, 1, 0, 1. So that would be 0, 1, 0, 1 is here, the letter O. And we can keep working our way through that. And eventually we find that that is the phrase, good day. All right, the star is a special character indicating end of message. So good day with the underscore to indicate a space. And then we have some big long data stream to convert. So let's, as usual, let's start with the example case. But both the example and the real data use this same set here. So I'm going to take that and close out this code from last time. And I'm going to save this as day 5. Let's call it lookup. That's my lookup data. And then I'm going to take our problem data here. And I mean, both in both here and here, really, I could just copy it in as a string rather than read it in from a file. Let's just have that as input data. Let's put it straight into a string. All right, save. This is day 5. So yeah, let's look up, let's bring this thing in. Day 5, lookup text. Okay, so I'm going to make it so that it's a 2-dimensional list again, where the letter is going to be the first thing, and then the number code will be the second thing. So let's do that. So for line in f.read.split lines, what are we going to do with each line? We are going to split it. And I think that should actually give me exactly what I want. Yeah. All right. So there's one item, there's the next, and so on. And it's all enclosed inside a second list. Okay. Because then that means I can search through both accordingly. Now I've got this input data. I need to convert this from hexadecimal into binary. So I've got the zeros and ones to do the lookup with. So right, let's just do the easiest way to do this. I mean, it's not tidy to have binary data as a string. It means we're using 8 bits to store what should be 1 bit of information, but it's going to be the easiest way to work through it. It feels really icky though. For each character in the input data, alright, so if I print that out, that's just going to give me every character in there. I can just do, right, I can get the binary value of that. Well, first I've got to get the, so Python has the bin function, right, which if I returns the binary representation of an integer. So I need to take the hexadecimal and turn that into an integer first. So to do that, I'm going to use the integer function on the hexadecimal character. Say this is base 16. And then feed that into the binary function. Take that integer, okay. And so if I print that out, yeah, there's all my hexadecimals turned into bits. I don't, now these are strings, and I don't want that leading 0b in front of it when I put it all in here as a string. So, all right. So if that's a string, then what I'm interested in for each string is from the second character to the end. Now, that's not quite what I want though either, because I need the zero padding. These are, so these, if this is hexadecimal, it has to be 4 bits. This is truncating off the leading zeros. And if I don't have those leading zeros, it's not going to work when I try to look it up against this. So if any of these are less than 4, I need to put the zeros on the left, give it the leading zeros. So this here should be 0, 0, 0, 1. Fortunately, Python again makes this nice and easy. There is the zfill function on a string. All right. Pad a numeric string with zeros on the left to fill a field to a given width. Okay, so I want it to be filled to take the string that's in B, zero fill it up to 4 places, and then save it back into B. That's not going to work because I only want to do that on this thing. So I actually want to do that to it first. All right, I want to chop off that 0b first. Otherwise, or I could have put a 6 there. But yeah. All right, there's what I want. Now I can actually put all this. This is going to look a little ugly for you, but it doesn't have to be split over multiple lines because that is B. So I can just put that on the end there. Here we go, same thing. All right, so take a character, base 16, turn it into an integer. All right, turn that into the binary string with a 0b in front of it. Give me the bit after the 0b and left pad it with zeros to make it 4 characters long. All right, now each of those I'm going to append onto this thing. All right, so binary data is whatever's inside binary data plus that thing. So now if I print this out, it should be exactly what I want. Okay. There's my data. Now, I can start looking it up. Like I said, storing zeros and ones in strings to convert binary data is not memory efficient. But the Python functions play with string data a lot nicer than dealing with individual bits. I can do it with the bits if I wanted to. But yeah, I think for beginning programs, this is probably the more straightforward approach. All right. That said, you are going to have to do some binary. I'm just thinking about some of the questions I've written for the 2002 challenge. Sorry, the 2022 challenge, the one coming up. You are going to need to know some binary bit level operations for some of those questions. All right, let's solve it with a string, and then I might do a follow up with the binary version. Okay, so zero. What have I got here? 1100. So that's right. So that was 7 characters there as a G. What do I want to do? What's the best way to manage this? So I've got this binary data, and I've got this lookup table. What's the lookup table called? Data. No, let's rename it to lookup, shall we? So that it makes more sense. All right, so starting from here, I want to loop through all of these. Now, the way this has been done, it is quite convenient. I can just see if it starts with a 0, it's going to be 4 bits. If it starts with a 1, 0, it's going to be 5. And if it starts with a 1, 1, it's going to be 7. So that's really quite convenient, isn't it? All right. Now I might do this as a while loop instead of a for loop, because rather than just saying looping through the binary data, because the amount that we're going to increment through the loop will change each time. Sometimes we'll read 4 characters, sometimes we'll read 5, sometimes we'll read 7. So the while loop will be more flexible for that. So while I is less than the length of the binary data. All right, so we want to read the first value, and if it's a 0, then we want 4 of them, and if it's a 1, we need the second value to know whether we need a 5 or a 7. Okay, so the first is going to be binary data I. If first is a 0, and remember these are all strings. All right, we want to read 4 characters, else that second is going to be binary data I plus 1, and if second is a 0, then we are reading 5 characters, else we are going to read 7 characters. All right. So what do I want to call this? Code, whatever. Okay, so I want to read. So from the I place, I want to read 4. Here I want to read 5. And so at this point, I want to increase I by 4 so that the next one I look at is 4 along from where I am now. This one I want to increase it by 5, so the next one I read is 5 along, and this one I want to increase it by 7. Okay, so I've read my code. And so if I print these out, there's my codes. Now I just need to convert them. All right. Let's make up a string called answer that I'm going to save these in. Okay, so to convert it, I know that looping through my lookup table, the first, so the 0th value is the letter, and the 1th value of each sub list is the lookup. So for each item in my lookup table, if item 1 is equal to my code, then the letter that I need is item 0, is inside item 0. And so I can just put that into answer. And okay, this will throw an error in a minute. No, it doesn't. Oh, and let's print out when I'm finished. Let's print answer. It's very nice that it hasn't thrown an error. Okay, good day. I thought it might try to read past the end because of the star. Because what I was thinking is here I would also need if code if that's a star, then we're finished. I is equal to the length of binary data, and that will finish it off for us. That'll exit that will cause that while loop to exit, and we just break out of the for loop that we're in. That's nice and tidy. Okay, good day. All right, and now I should just be able to copy and paste this thing in. And there it is. Okay, and this has been, I might do the binary version as a separate video. Yeah. All right, this is Mr. Ballgarden signing out.